In the first part, we have come a long way understanding how to turn on an LED safely.
No.
And how to tie them together. Now we can try our parallel network to see if it works. So now we are ready and I'm plugging in 15K and 10K resistor tests. And I'm switching it on. I just wonder how long it's gonna work. This setup has worked for over 1 minute, and after I turned it on again, the LED has failed. So I can turn it off. Okay, so let me take that out. The resistors were freakingly hot. They almost roasted my fingers, so I thought maybe I have to reduce the current a little bit. So now I increased the resistor by adding a series 5K composed of two parallel 10Ks, each rated about 2 watts, and connected a voltmeter to measure the voltage around one of the 6K networks, which is about 78 volt RMS, and that means around 4 volts RMS left for the LED, which is not harmful. But unfortunately, this setup also failed after around 2 minutes. So we probably might have missed something. LEDs are diodes and they have reverse breakdown voltage. In other words, they can conduct even when you invert the voltage across it. And this current after the breakdown voltage can damage the LED immediately. In datasheets we found this voltage was 5 volts, but probably the LEDs that I'm using have a couple of volts for breakdown voltage. That's why when the negative cycle of the AC voltage exceeds this rating of breakdown voltage of our LED, simply stops working. This is probably the reason why our LEDs keep failing even if we are using the proper level of resistor. So if we connect a component which will ensure that the voltage level will always be lower than the breakdown voltage across the LED, then we will ensure the operation of the LED provided that our resistors are properly chosen. So probably the component we are looking for is exactly a diode. A usual diode will ensure the voltage will always be lower than the breakdown voltage across the LED, because a diode, like the LED, because LEDs are also diodes, will always have a forward voltage when they conduct. So that means we can connect the positive terminal of the diode to the negative terminal of the LED and vice versa. For a usual diode, the forward voltage is around 1 volt. That means our reverse voltage across the LED cannot exceed 1 volt. Because of that, our diode will start conducting current, and that will almost short LED and bring down the reverse voltage of LED around 1 volt. So here I found ordinary 1N007 diode and connected across my LED. So what we have to be careful about here is that the polarities of the diode and our LED should be in the reverse order. In other words, the positive terminal of the LED should be connected to the negative terminal of my diode and vice versa. So now I can plug it in. Okay. And now we expect much stable operation. I'm switching it on. Yes, as you can see, it's stable. And let it rest and see how long it will operate. So almost 10 minutes passed and it's still working. So we are convinced that it will work for a long time, maybe for the next 10 minutes more. So I can turn it off. So our success is the result of our determination, thinking, researching, and a little bit of madness. Please do not try none of the things I have done in this video at home, because I'm an educated ignorant. So we can light up an LED with a very simple and silly circuit plugged to main electricity, and it works fluently. It still works, and honestly I don't know how long it can maintain like that without burning. But one thing, is certain here. That is the power of knowledge and science. There is nothing that you cannot accomplish. But actually what we can learn from that is we can build a simple night lamp out of a couple of resistors, a diode and an LED. I don't know, but maybe with this setup it might last as long as for the next 10 years.